Okay, tonight we're talking about 2.6 special functions. One of the essential understandings here is this. You guys need to know or be able to look at graphs or functions and determine what kind of graphs they are. A linear equation is pretty easy to find. It's a line. We're also going to talk about step, absolute value, the constant function, and identity functions just by looking at their data or looking at the function as a graph. And we're going to start out with this mail problem here. This is a special function. It says the cost of postage to mail a letter is a function of the weight of the letter. Is this a linear function? Yes or no? Well, let's look at that a little bit. You can see right here, if it's 1 ounce, it costs 39 cents. What if it's half an ounce? Is it less than 39 cents? No. If you look at it this way, that's 1 ounce, that's 2 ounces, and we'll just go with that. Anything between 0 and 1 ounces is going to be 39 cents. So let's say this is 39 cents right here. At 0, that means there's no letter, so that costs 0. And it stays 39 cents until it gets to the 1 right here. Once it goes above 1 ounces, let's say it's 1.01, even then, it's going to jump up to 63 cents. So I'll put a little circle right here because at 1 ounce, it's still 39 cents. But if it's a little bit more than 1 ounce, then it jumps up to 63 cents. So if it's 1.5 ounces, it's 63 cents. Now you can see there's two pieces to this graph, this piece and this piece right now. This is not a linear equation or not a linear function because it's not a line. There's two different chunks of a line there, I guess you could say. What is the cost of 1.5 ounce letter? Well, we just decided that 1.5 ounces is going to jump up here. It's going to be 63 cents. So what we're talking about here is a step function. A step function is a function in which there are intervals for the independent variable x for which there is no change in the independent variable y. So as x is changing along here between 0 and 1, y stays the same. So as x changes, y stays the same until it gets to a certain interval, and it jumps up to the next interval for y, which is a typical step function. Here's another step function. It's called the greatest integer function. You can see there's, and this is a way to tell this is a step function. You'll see this, intervals between -3 and -2, -2 and -1, -1 and 0. This is a perfect example of a step function. And what it means is this. The symbol, with its two sets of brackets here basically, the symbol, it's called the greatest integer function, means the greatest integer less than or equal to x. So for example, this is the greatest integer of 7.3. What's the greatest integer less than or equal to 7.3? Well, that's just going to be 7. Not 8, but 7. -2.4, the greatest integer of that, that would be -3. You got to think you're going to the left. -3 would be smaller. -3 would be over here. -2 would be over here. The smallest integer less than or equal to -2.4 is definitely going to be -3. So if we look at this one, which is a step function, less than or equal to 1, I'm sorry, less than 2 and less than or equal to 1. That's everything between 1 and 2. That's going to be equal to 1. So if you go between 1 and 2 right here, you can see the step is at 1. But as soon as it jumps up to 2 right here, it's between 2 and 3. So the smallest integer in between these two is going to be 2, and that's this part right here. Step functions. Here's a real world step function. No Leaks R.Us Plumbing Company charges $60 per hour or any fraction thereof for labor. So for like a half hour, it's still going to cost $60. If it's 1.5 hours, you got to go up to 2 hours. It's going to be $120. So filling in this table here, anything between 0 and 1 is $60. What about between? It's less than or equal to 2. If it goes above 2, then we jump up into the 3-hour category. Between 1 and 2 hours, that's going to be $120. Between 2 and 3 hours, let's say it's 2 1/4 hours or 2 3/4 hours. Doesn't matter. It's still going to be 180 bucks. So if you look at this table here, here's 1, here's 60. Anything between 0 and 1 here is going to be $60. I'm going to open this circle up here at the end because if you don't work at all, you don't make any money. So that would be 0. But if it's 1 minute even, it's going to go right to here. It's going to be 60 bucks. As soon as it's over an hour, we're going to jump up to 120 here. Now, if it's still 1 hour, it's still $60, so it's down here. But as soon as we get a little bit above 1 hour, it's going to jump up to the 2 hour rate, which is $120. And if you go to above 2 hours, open-ended circle here because 2 hours is still $120, but anything over 2 and between 3 is this, and so on and so forth. And you could jump up here. This is your typical step function. Constant function, pretty easy one. They have f of x right here equals 3. Now a constant function just means this. You just have a number over here. No variable. Now remember, you can replace f of x with y. So this is no different than y equals 3. There's no variable x. And what that means is x could be anything. If you set up 3 ordered pairs for this constant function where it's just y equals or f of x equals some number like this, y is always going to be 3 no matter what. And x could be anything. How about 1? How about 3? How about -4? No matter what you plug in for x, x could be anything basically. Y is always going to be 3. And if you graph these, over 1, up 1, 2, 3, that's this point. Over 3, 1, 2, 3, and up 1, 2, 3, that's this point. And -4, up 3. You can see it's a horizontal line. And that's because there's no variable x. Your slope of this line is 0. Anything times 0 or is 0. So you're basically multiplying 0 by x, so it gets rid of it. This is the constant function. Identity function is just what it is. The identity function right here. F of x equals x. Or basically y equals x. And what that means is, if you were generating ordered pairs for this function, well, one thing holds true. Whatever you plug in for x is going to be equal to y. Let me move this. Oh, I can't move it. So let's say I plug in y equals x over here. Let's say I plug in 3 for x. That means y also has to equal 3. How about -1 for x? Well, that means y also has to equal -1. Whatever you plug in for x, y is the same thing. Giving you this diagonal line here right through the axes. You can see, what's the first one I did? 3, 3. Over 3, up 3. This is this point. -1, -1. 2, 2. Whatever the x value is, the y value is. This is the identity function. Next, we're going to go with the absolute value function here. And this will be the last one, and then I will talk about the last function we're going to work on in the notes. We'll work on that tomorrow. Absolute value function, you got to remember this. This is the most basic absolute value function. F of x equals the absolute value of x right here. No matter what you plug in for x, now remember, this is y over here, same thing, absolute value of x. And they want us to plug in -3 for x. So y equals the absolute value of -3. Well, what's the absolute value of -3? +3. Plug in -2. What's the absolute value of -2? +2. +1. When you plug in 0, you get 0. When you plug in 1, what's the absolute value of 1? 1, 2, 3. So there's our ordered pairs. -3, 3. It's this point right here. -2, 2. -1, 1. There's 0, 0. 1, 1. And now it becomes the identity function, basically 2, 2, and 3, 3. It's a perfect V here is what it is. It's like bending a line, I guess you'd say, but it's not a linear function. This point right here, the bottom, I call it the vertex. the very bottom point. Now, when you're graphing these absolute value functions, you want to find the vertex first. And once you graph the vertex, it's basically up 1 over 1, up 1 over 1. The slope is 1. On this side, you got to imagine if you were graphing this from scratch, you get the vertex and you just start graphing these points here, slope of 1. If you look at it in front of the x here, in front of the absolute value, there's no number there, so it's kind of like a 1. But how do you get this other line? This is a negative line. Well, it's just the opposite. It'd be negative 1. So you could say up 1, back 1, up 1, back 1, up 1, back 1. So the slope of this side is 1. The slope of this side is negative 1. But that's the most basic absolute value function. And whenever you graph absolute value functions, you kind of base it off from that. Okay, the first thing I want you to notice here is this is number 2 down below there. And I added a 2 here. We added 2 to the outside. So it's the absolute value of f of x equals the absolute value of x plus 1 plus this 2 here. So put that in there because that's going to help us learn how to graph these a little bit better. Okay, the first thing is this. What is outside the absolute value with x? What is out inside the absolute, I'm sorry, what is inside the absolute value of x shifts the vertex to the left or to the right? Okay, we got 1 in here with this x in the absolute value. That's going to tell us if it shifts to the left or to the right. And you'd think being it's positive 1 that we're going to shift our vertex to the right, but we're not. We're going to shift it the opposite. This plus 1 here means shift vertex negative 1, basically. You're going to move it to the left. So instead of our vertex being here in the middle, we're going to shift it over to here now. We're going to shift it 1 unit to the left. So if the number is positive, shift to the left. If it's negative, you shift to the right. Well, the 1 tells us it's positive. We shift the opposite, and that's to the left. Okay, the next one here. The number outside the absolute value being added or subtracted. Okay, that's this one right here. The plus 2 on the outside of the absolute value. Moves the vertex up and down. If it's positive, move graph up, and then vice versa. So it is positive 2, and you do the same thing here. So we're going to move vertex up 2 units. So we had to shift it to the left 1. Now we're going to move it up 2 units. Okay, so our new vertex shifted from the vertex over to the left 1 and then up 2. So here's my vertex. And then just remember, absolute value is a V, perfect V. It's a slope of up 1 over 1. You can put as many points in as you want. And then mirror images on the other side. So this point mirrors up with this point over here. So up 1, back 1, up 1, back 1, up 1, back 1. And this would be our absolute value function. You can look some of these up on YouTube if you want. There's some pretty interesting stuff out there. I'm not kidding. And we will finish this up tomorrow.